second collides with another identical ball at rest. So identical. So mass, you can take it as same. M1 is M, that was initially moving with a speed how much? 9 meters per second. It collides with another body whose mass is same, but initially that is at rest. After the collision, the direction of each ball makes an angle 30 degree with the original direction. So initially they were moving like this, now they are making 30 degree. So one should move at the top and the second has to move at the bottom. Both cannot move in the upward direction because there is a reason. This is V1 and this is a V2, each at an angle 30 degree. See why they should move like this, why both can't move like this? No, it cannot move like this, they have to move like this. The reason is because in collision we know momentum will be conserved, isn't it? This is before collision and this is after collision. Now since you have the velocities at a certain angle, so we need to resolve the velocities, isn't it? So one velocity you will get in this direction. So this is a V1 cos 30 degree and this is a V1 sin 30 degree, and same thing for this also. This is V2, so this is going to be V2 cos 30 degree and this is V2 sin 30 degree. Now you can see that masses are same, velocity, if masses are same, isn't it? If masses are same, then what will happen? Since the velocities are acting in opposite direction, then there is a possibility that two will cancel out. So momentum will become zero in the vertical direction, and yes, there was no initial momentum in the vertical direction. So you know initial momentum has to be equal to final momentum, isn't it? Initial momentum along the y-axis. I'm not interested in the x-axis because he's asking me the ratio x by y. X is actually V1 and y is nothing but V2, the velocity is after collision. So along the y-axis there is no initial momentum, so finally it should be 0. If the initial momentum is 0 along the y-axis, finally also after collision it has to be 0, and that is possible only if the two balls move, one up and one down. If both are moving in the same direction, then what will happen? So if you say this as V1 and say this as V2, and then you will get both for both, correct? If you resolve, you will get both the components in the upward direction, and these two components will add up, and addition cannot be 0, isn't it? So both the particles will be moving, having momentum in the y direction along the positive y-axis, so they will add up. But requirement is that momentum along the y-axis should be 0. Along x-axis it is there. So along x-axis not a problem. Along y-axis it should be 0. That means the two balls have to move, one up and then the other down, isn't it? And it's a standard question. It is also seen from the NCERT worked example, wherein collision in a 2 dimension is being discussed there. So initial momentum along the y-axis is 0 before collision. There is only along x-axis. Finally along the y-axis for the first particle M, the velocity is upward, so we can take it as a V1 sin 30 degrees half, plus for the second body, momentum after collision is mass into velocity. Velocity is downward, so this is V2 sin 30 degrees again half, so this is coming out to be minus V2 by 2. So m by 2, that will go that side, it will get divided by 0, so that is 0. So therefore you will get V1 minus V2 equal to 0. This implies V1 is equal to V2. Therefore if you take the ratio x by y, which is a V1 by V2, so that is coming out to be 1:1.